Hi, and welcome to our first episode in our Crossplane YouTube series taken from my Crossplane 101 course. Let's go ahead and get started. In episode 1, we're going to talk about why platform engineering matters. And to start us off, let's talk about the infrastructure problem. And this is where the platform team is really drowning in requests. So you might have a flow like the one on the screen here for a developer that needs a database. They first file a ticket, then they wait 3 or 4 days, then maybe they got the wrong configuration. They go ahead and file another ticket, they wait again, and on, and you might get your database in a couple of weeks if you're lucky. Also, the daily reality is that developers spend 30 to 50% of their time waiting for infrastructure and having to deal with infrastructure. So things like AWS console for some resources, you might be looking there. You also might be using Terraform for other things, CloudFormation for some legacy work in AWS, a different CLI per cloud, manual approvals everywhere. So that's the daily reality that developers have to deal with. And we want to make developers' lives easier through platform engineering. So what does platform engineering solve? We have a few problems on the screen for you. The first is ticket queues, and we solve that with self-service infrastructure. You also have inconsistent configurations that you might run into, and we solve that with golden paths with some reasonable defaults. You might also run into cloud complexity, and we solve that with abstraction layers. And then finally, knowledge silos, and we solve that with platform as a product. So what is Crossplane? Well, it's a Kubernetes add-on for your infrastructure. It will turn your cluster, that's the Kubernetes cluster, into a control plane. It's declarative, API-driven in its approach. You get continuous reconciliation, auto-healing, and you don't have to worry about drift and the issues that come with drift. And also, there's no state file to have to manage, like the case with Terraform. You manage cloud resources just like you would normally manage your application resources using kubectl. And eventually, you're going to go and use Argo CD or Flux in a GitOps pattern. Quick comparison between Crossplane and some traditional infrastructure as code tools like Terraform. So the first thing with traditional infrastructure as code tools is that you get a lot of separate tools. You have to use Terraform with Ansible and so on. Manual drift detection, that's an issue. If you're using Terraform, you need to run Terraform plan manually multiple times, or you might want to automate it, but it gets really complex fast. And then you have state file management. So the state file for Terraform, you have to find a way to secure it and manage it properly. And then different workflows you might run into as well. With Crossplane, it is Kubernetes-native. So if you're a Kubernetes shop, you'll feel right at home. There's automatic reconciliation, no problems with drift. Kubernetes etcd is where basically the state lives. So it's using that as a database. There's no files to worry about. And then you use Crossplane similar to how you configure your applications or run your applications. All is done through Kubernetes native tools. In this episode, what we're going to demo is how to install Crossplane on Kubernetes. We'll explore the CRDs that are created. CRDs stand for Custom Resource Definitions. And then we're going to look at setting the CLI tools and finally configuring multi-tenant RBAC. So let's go ahead and jump into our demo. But before you go anywhere, by the end of this video, we're going to see what we'll cover in episode 2. So stay tuned. Just a quick plug before we continue. This video is part of my Crossplane 101 course where we dig much deeper into Crossplane and how to build your real internal developer platform. We cover Kubernetes cluster setup, AWS provider integration, compositions and XRDs, packaging and deployment, GitOps operations, Crossplane version 2 migration, and the course includes over 15 hours of video and 7 hands-on labs. You also get a certificate at the end, and you also have a 30-day money-back guarantee. If you're interested, check it out in the description below. All right, let's get back to our lesson. We're here in the Academy, and let's jump into our Crossplane 101 course. Continue learning. And we're interested in jumping straight to our first lab here, setting up your Crossplane platform. I already started the lab, so we can jump in and enter the lab right away. And what we're going to do, if you look at the progress here, we're going to start the Kubernetes cluster with Minikube in this first task. Then we're going to install Crossplane with the production config. And then we're going to configure platform engineering RBAC. So let's go ahead and get started. Step 1, start Minikube cluster. So let's clear here and let's paste this. What this will do, it will go ahead and start Minikube with 2 CPUs. And let me just make this a bit bigger. And we see the Kubernetes version 1.32 driver Docker. So give this a minute or two until we're ready to go. All right, looks like it has completed. So we can run the kubectl cluster info command here. And yes, it looks like everything is running nicely. You can see Kubernetes control plane running at this address here. Core DNS is running and so on. So clear that. Let's verify the cluster health. So a bunch of commands here to make sure that is working well. kubectl get nodes. We only have one node running well. And again, version 1.32.0. We can also check the kubectl get pods with the kube system. So we have a bunch of pods running here in kube system, all standard for Minikube. And you can also verify that you can create resources by running this command, which is really helpful when it comes to checking against RBAC. And then we can create some namespaces for platform engineering. So we can go ahead and create a Crossplane system namespace. And we can create a namespace for a platform team and maybe one for a backend team and one for a front-end team. If you run kubectl get namespaces, you'll see all the namespaces created right there. And you can also run this command kubectl get all against all namespaces. And this will show you the pods running, also the services, the daemon sets, if there is any deployments, replica sets. So it gives you everything in kind of one command. Again, it's against all namespaces. All right, so we're good to go, and we are ready to go ahead and move on to the next task. So again, in this task, we're going to install Crossplane with production configuration. Let's clear here. And first step is to add the Helm repository. So let's do that. Do a repo update. Let's search for the Crossplane Helm chart. It's right there. We can create a Crossplane values file. And we can create this file in the scripts tab right here. And let's give it a name, Crossplane values.yaml. And copy that and put it in there. So this is the values file that we have here. So you can see what image we're going to use, resources, security context, and a few others. And now we can install Crossplane with this command. So change directory into the scripts folder and then run the Helm install command like that. This wait flag makes sure that it will wait until Crossplane is fully deployed. And once that's done, takes about half a minute or a minute. We'll be able to check for ourselves. All right, this looks good. Let's change namespace into Crossplane system. And now let's clear and run Helm ls or Helm list. And from here, we can see that we have our Crossplane chart running here, and the app version and everything else is good. You can also run kubectl get all. And you can see that it installed 2 pods, an RBAC manager and the main Crossplane pod. We have a service and we've got the 2 deployments here with the 2 replica sets. So this all looks good. Next, we want to install the Crossplane CLI. This helps with debugging, development, managing Crossplane resources. I like it quite a lot when we're debugging specifically and running some monitoring commands. So you can run this script right there, change permissions and move it to this location. And now you can just simply run the Crossplane binary. Here's Crossplane version, shows you the client and server versions, which is perfectly what we want. Finally, step 5, let's explore some resources. We'll explore the custom resource definitions. So let's clear here so we can see it better. Here's a bunch of CRDs that got installed with the Helm chart from Crossplane. So you can see composite resource definitions, composition revisions, compositions, configuration revisions, configurations, and so on. So all this we will use with Crossplane. You can also run kubectl get providers. You can see providers here is a custom resource definition. So this didn't exist before we installed Crossplane as a Helm chart, and that's what Crossplane is. It's an add-on to extend Kubernetes. So now we can use Crossplane to start to create resources in AWS, on-prem, in GCP, and so on. So here we can see that we don't have any providers as of yet, but all I want to show you is that these custom resource definitions you can use directly, just like you're looking up pods or deployments that are native to Kubernetes. You can now do the same thing for Crossplane custom resource definitions. So that is all I wanted to show you in this task. We can jump on to the next task, where we're going to create some RBAC, which is typically what you want to have when you are running Kubernetes in production in general. And from a platform engineering perspective, you want to have different roles. So we'll see that right now. The first thing we want to do is create a platform admin role. So we can go to the manifests folder here, and let's create a new file, and we'll call this file platform admin role.yaml. And in here, we're going to paste this Kubernetes manifest. It's a cluster role, and you can see the full Crossplane permissions, Kubernetes cluster administration as well. Here's all the here's the policy that will allow us admin access. All right, now let's go ahead and create a cluster role for the platform operator. This is a new role, so new file, new manifest. We'll call this platform operator role.yaml. Let's copy that again, put it here. As you can see, this is a new role. And time, instead of showing everything here, we were allowed to do pretty much almost everything. Here we are restricting it a little bit more. So you can see the restrictions in here, what we're allowed to do, what API groups, what resources. It's another role. And now we can also add developer team roles as well. So we can create a new file for a new manifest. And this one, we're going to call it, let's see here, Crossplane developer role. And just copy this right here and create the file, create, copy our manifest, just paste it here. All right, you can see what this role allows. And now we can actually create, instead of a cluster role, we're going to create a role. Cluster role applies to the entire Kubernetes cluster, and a role can namespace, so it applies to a specific namespace. In this case, we created a Crossplane developer role here. Now we're going to create a backend team developer role. So new file, backend team developer role. Copy that, put it in here. There you go. So it's tied to the namespace backend team, and this is what they're allowed to do in here. And once we've defined all these manifests, we want to apply them, right? So this is a declarative product, which is Kubernetes, and we want to be able to apply everything we've just created right here. So all the different roles that we have, 4 of them, we're applying them one by one. Let's verify that it all got created with the kubectl get cluster roles. You can see 3 of them had cluster roles, and there's only one that is just a role, which is the backend team. All right. So far, we just created roles. These are policies, but you don't really do anything unless you create service accounts that can reference these roles for the permissions that you allow. So let's go ahead and create some service accounts. We're going to create one service account here for the platform admins in the platform team. And we can create a service account for the platform operator and one for the backend team. And let's create one for the front end team. Let's check the service accounts were created for the platform team. You can see here we got the platform admin, platform operator, and the service account for the backend team. And finally, a service account for the front-end developer and the front-end team. Now, these are service accounts, but they have no permissions, right? So they need to be tied to the roles or cluster roles that we created. So we need to create something called cluster role bindings. We can do that by creating a new file, and we call this role bindings. So we're binding the service accounts to the roles that we created, whether they're cluster roles or just simply roles. So this is a cluster role binding, which will bind a service account to cluster roles. So cluster role binding, as you can see here, we've got the service account platform admin is tied or bound to the cluster role platform admin, and the platform operator is bound to the platform operator, the service account to the role, the cluster role, and then the backend developer to the Crossplane developer. And finally, a role binding here for the backend team with the backend developer to the backend team developer. So that should all be good to go. And you can, in Kubernetes, if you're familiar with Kubernetes, you can, of course, add multiple manifests in one file. This is just simply YAML, and just separate them with these 3 dashes. And then once you do that, we can just run one command that will take care of deploying everything for us. So you see 4 manifests were deployed, 4 objects were deployed for us. Let's clear this and take a look at the cluster role bindings that we created. So you can see 3 of them here, and then we have 1 role binding that we created as well. All right, that's all good. Now let's go ahead and test all this, right? It's nice that we've created it, but there is a way to test it. I kind of alluded to that in the beginning of this demo, but you can run this command kubectl auth can I access everything here as a system service account platform team? And the answer is yes, which is good. Let's go ahead and run this command. Can I create providers as a system service account team platform operator? Yes, so that's good. And then let's try something that will show us a no. In this case, can I delete nodes with the service account platform team platform operator? And in this case, it's a no. Here's another test. Let's see if we can test whether a developer can create pods in their own namespace. So this is accept. So you can see create pods in the namespace backend team with the service account backend team, backend developer. So that worked. Here's another one. We want to test, see if the developer can create Crossplane providers. In this case, they cannot. Okay. And one more. So test if developers can or cannot access other teams' namespaces. In this case, they cannot as well. And really, that's what I wanted to show you from an RBAC perspective. So as you're building your internal developer platform and providing that to platform engineers and developers and anybody else on your team, you need to have these roles in place. You need to have those bindings in place and RBAC set up in a way so that people don't step on each other's toes and everybody has the work that they're allowed to do. And that is what I wanted to show you here, because again, this is a platform that you'll build and providing it to your application developers and also your infrastructure team. In our next episode, we are going to talk about cloud resource control. We're going to connect Crossplane to AWS. You'll see how to install provider packages, how to configure authentication, and create real cloud resources. You'll watch drift detection in action. So stay tuned and wait for episode 2, Managing AWS through kubectl. And if you want hands-on practice, again, you can check out the Crossplane 101 course link in the description, and you'll be able to run the labs yourself and watch the videos as well.